everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about smart materials and their engineering applications. In these smart materials, mainly we discussed about shape memory materials. Best example is polylactic acid. So today topic is smart materials and their engineering applications and shape memory materials and polylactic acid. So what is smart materials? Generally in nature, different types of materials are available. For example, wood, composites, ceramics, smart materials. So many different types of materials available in nature. So all these materials, smart materials is most important nowadays, most preferable materials. Why? Because the smart materials have properties that react to change in their environment. So these smart materials have properties. So these properties they can change with their environment. It is self-motivation. That materials are called smart materials. So these are having properties that react to change in environment. So that's why these materials also called as intelligent materials or responsive materials. So what is meaning of smart materials? So smart materials have properties that react to change in environment. So those materials are called smart materials. Self-motivated materials are called smart materials. So this means that one of their properties can be changed by external conditions. So generally, just now we discussed already, smart materials are having properties. These properties they can change with their environment. That means physical conditions. So that means external conditions such as temperature, light, pressure, electricity, voltage, pH and chemical compounds, etc. So the smart materials they are having properties. The properties can change with their environment or external conditions such as temperature, pH, pressure, electricity or any other chemical compounds affecting on this materials. So they can change their properties according to environment. So this change is reversible and can be repeated many times. So these changes are reversible and repeated several times. So these materials are called smart materials. So these materials play a crucial role in various engineering applications and other fields also. It plays an important role. So here the smart materials are also called as intelligent materials or responsive materials. So these are designed materials that have one or more properties that can be significantly changed in controlled manner. That means external stimuli such as stress, pH or any other chemical factors or light. So any other external stimuli, that means external conditions. So these materials change their properties. So these type of materials are called smart materials. Nowadays, these materials plays an important role in this various engineering applications and other fields also. Most preferable materials because they are having their properties and they are changing with the external conditions or with the environment is called smart materials. So the smart materials are classified into 7 types. So now let's discuss classification of smart materials. So here they are classified into 7 types. Piezoelectric materials, shape memory alloys. These materials are most important and preferable materials used in this engineering and other industries. We are using this shape memory alloys. And magnetostrictive materials and electrological and magnetological fluids. Electrological and magnetological fluids and smart polymers and thermochromic and photochromic materials and hydrogels. So the smart materials means they are having properties, they change their properties with environment conditions or external stimuli. So the smart materials again classified into 7 types. Piezoelectric materials, shape memory materials, magnetostrictive materials, electrological and magnetological fluids and smart polymers and thermochromic and photochromic materials and hydrogels. So now discuss what is piezoelectric materials. So piezoelectric materials or piezoelectrics are the materials that can produce electrical energy upon the application of mechanical stress. So what is the meaning piezoelectric materials or piezoelectrics means? For example here, when we applied force on this material, when we applied force, so in this case it produces electricity. It produces electrical energy. Electric energy. It produces electric energy. So piezoelectric materials means the materials when we force apply, when we stress these materials or we apply force on this material surface. So in this case it produces electrical energy. The best example is commonly known as piezoelectric material is quartz. The best example of piezoelectric material is quartz. So the mechanism involves in this development of electrical charge due to movement of electrons. Due to movement of electron upon application of stress. So when we applied stress on this material, it produces electricity. So this electricity produced due to the movement of electron. It depends on application of stress on material. Is called piezoelectrics or piezoelectric materials. So this piezoelectricity was discovered by Curie brothers in 1880. So this piezoelectricity was discovered in 1880 by Curie brothers in quartz. So simply we say piezoelectric material means when we applied stress on material surface, it produces electricity. That is called piezoelectric materials. Best example is quartz. First it was introduced or discovered by Curie brothers in 1880. So what are the engineering applications of piezoelectric materials? So these piezoelectric materials used in sensors and actuators. So these are used in sensors for pressure, acceleration and force measurements, as well as actuators for precise movements in devices such as inkjet printers. So these piezoelectric materials used as sensors and actuators were used in sensors for what purpose? Pressure, acceleration and force measurement, as well as in actuator for precise movements in devices. So such as for example inkjet printers. So in this case this piezoelectric material used as a sensors and actuators. And also used energy harvesting. Energy harvesting, that means convert mechanical vibrations into electrical energy. So when we applied stress on this piezoelectric material, it produces electricity. So in this case, these materials used for energy harvesting purpose, that means convert the mechanical vibration into electrical energy for powering small electronic devices. For powering small electronic devices. So that purpose we are using these piezoelectric materials. So some of the natural piezoelectric materials given here in this image. One is quartz. So first introduced piezoelectric material is quartz. It was discovered by Curie brothers in 1880. So one more example is topaz, dentine, tendon, rochelle salt, DNA, sugarcane, bone, scarlet tourmaline. So these are the natural piezoelectric materials. So used for engineering applications. For example, it is used as a sensors and actuators and also used in energy harvesting. So in this case, mechanical energy, mechanical vibrations into electrical energy. This is used for powering small electronic devices. So second type of smart materials are shape memory alloys. Shape memory alloys. So shape memory alloys is an alloy that can be, the alloys means mixed of metals. So this shape memory alloys is an alloy that can be deformed when cold. It can be deformed in cold condition, and when we cool it can be deformed, but returns to its original shape, that means free deformed or remembered shape when heated. That means it depends on temperature. So what is the meaning of shape memory alloys? these shape memory alloys are that can be deformed when cold, but it returns on its to be free deformed. That means it retains original shape when we heated. So it depends on temperature only. The type of it based on temperature, it remolded. This property of shape is changed. So during cooling condition or when we cool, it can be deformed. The shape is deformed. When we heated this one, it can pre-deformed. That means remembered. Original shape maybe. That is called shape memory alloys. For example, you see, this is the original shape of tube or pipe, anything. So when we bent this one, that means for example, when we applied cool, it is deformed. When we applied force or cool conditions, so it is deformed. So during heating process, it can be original shape. That means it is pre-deformed or remembered. So this type of materials are called shape memory alloys. They can change their shape or size according to with respect to temperature. So where we can use this shape memory alloys. So these are used in biomedical devices. The shape memory alloys used in biomedical devices. So used in stents. For example, these shape memory alloys used in biomedical devices. So for example, used in stents. So that can be compressed for insertion and that expand to their original shape within the body. Here in this image, it clearly shows that generally this shape memory alloys used in this biomedical devices, for example, used in stents. So that can be compressed. That can be compressed for insertion and then expanded to their original shape within the body. So this shape memory alloys also used in this aerospace. For example, deployable structures and adaptive wing components in aerospace applications. So these materials used in this aerospace industry also. So here deployable structures and adaptive wings components in aerospace applications. So some of the applications of shape memory alloys are used in medicines, optometry, engines, aerospace, robotics, automotive, civil structures and textile industry also. We are using this smart materials, that means shape memory alloys. So third one is magnetostrictive materials. So in this magnetostrictive materials are used to convert electromagnetic energy. So these materials are convert electromagnetic energy into mechanical energy. So in this magnetostrictive materials means which converts electromagnetic energy into mechanical energy. So this effect can be used to create sensors that measure a magnetic field or detect a force. So these materials change their shape in response to an applied magnetic field. So magnetostrictive materials means these are used to convert electromagnetic energy into mechanical energy and vice versa. So in this case, this effect can be used to create sensors so that measure a magnetic field or detect a force. So these materials change their shape in response to applied magnetic field. So these materials are called magnetostrictive materials. So simply we say electromagnetic energy changes to mechanical energy, vice versa. So where we can use these magnetostrictive materials? So mainly preferred in this engineering field. For example, engineering applications of magnetostrictive materials. Here it is used as sensors and actuators. Actuators. So utilized in sensors for measuring magnetic fields as actuators for precise controls in robotics. So here, so this electromagnetic energy converted to mechanical energy. So fourth one is electrological and magnetorheological fluids. Electrological and magnetorheological fluids. So what is the meaning of these fluids? So these are fluids whose viscosity can be changed. Whose viscosity can be changed in character or composition by applying electric or magnetic field. So what is the meaning of electrological and magnetological fluids? So those fluids are, these are the fluids, so whose viscosity can be changed in character or composition by applying electric or magnetic field. By applying electric or magnetic field. So what are the engineering applications of this electrological fluids? So it is used dampers and shock absorbers. Dampers and shock absorbers. So used in automotive and industrial applications. So this dampers and shock absorbers are the best example of electrological fluids materials. So here these dampers and shock absorbers generally used in automotive and industrial applications to adjust suspension characters based on changing conditions. Based on changing conditions. For example, dampers and shock absorbers. So here these electrological and magnetological fluids. So these fluids whose viscosity can be changed into character or composition. So by applying electrical field or magnetic field. And next type is smart polymers. So polymers that undergo reversible changes. The polymers that undergoes reversible changes in their properties in response to external stimuli. So smart polymers, polymers means these are poly means many, mer means parts. So number of compounds combined to give polymer. So usually polymer is a high molecular weight compound. So here what is the meaning of smart polymer? So polymer that undergo reversible changes in their properties. So it is one of the best example of smart material, because smart material means they are having properties they can change with their environment conditions or external stimuli. So you see in the same way smart polymers also that undergoes reversible changes in their properties. So in response to external stimuli. External stimuli means external conditions such as pH or force or any chemical compounds or physical factors, etc. So many, any external conditions effects on that material, they change their properties, such as called smart polymers. So what are the engineering applications of smart polymers? So these polymers are used in biomedical devices. So these smart polymers are used in biomedical devices. So used in drug delivery systems. Used in drug delivery systems and as responsive coating for medical implants. So the smart polymers used in drug delivery systems and as responsive coating for medical implants, and also used in textile industry also. So here responsive fabrics for application like moisture management or color changing textiles. So that purpose we are using in these textiles is smart polymers. So next one is thermochromic and photochromic materials. Thermochromic and photochromic materials. So these photochromic materials are able to change color when irradiated with visible or UV light. So these materials when absorb visible or UV light or irradiated with visible or UV light. So in this case these materials change their color. So the type of materials are called photochromic materials. So what is the meaning of photochromic materials? So these materials are able to change color when irradiated with UV light or visible. What is the meaning of thermochromic materials? So these materials also undergoes color change when heated above or below threshold temperature. So thermochromic and photochromic materials, these materials change their color or properties when interacting with UV light. That materials are called photochromic materials. If the materials undergo color change when heated above or below critical threshold temperature. So that materials are called thermochromic materials. So what are the engineering applications of these thermochromic or photochromic materials? These are used as smart windows. So windows that automatically adjust their tint based on sunlight intensity. Tint means shade. So this thermochromic and photochromic materials used in these smart windows, that means windows that automatically adjust their shade based on sunlight intensity. Based on sunlight intensity. So packaging. So packing purpose also we are using these materials. So indicators for temperature sensitive products. So for example here, when it interacts with heat or UV radiation, this material changes the color. Here for example, this glass absorb, it changes the color by increasing the temperature or attracting the irradiation with UV radiation. Glass color is changed. So last type of smart materials are hydrogels. So what is the meaning of hydrogels? So water absorbing polymers. Water absorbing polymers that can change their size and shape. Water absorbing polymers that can change their size and shape in response to environment conditions. So based on environmental conditions, these hydrogels are change their size and shapes. Hydrogels, that means water absorbing polymers. So those polymers change their size and shape in response to the environmental conditions is called hydrogels. So now let's discuss engineering applications of hydrogels. So these are used in biomedical field. That means, for example, used in drug delivery systems or wound care and tissue engineering, because due to their high water content and biocompatibility, non-toxic nature. So that's why most preferred in this medical application purpose, we are using this hydrogels. So these engineering applications of smart materials continue to expand in researchers and engineers explores. So new ways to leverage their unique properties for innovative solutions across various industries. So that's why in recent years most prefer this smart material, because they are changing their properties according to situation or according to environmental factors or external stimuli. So that's why these materials continue to expand as researchers and engineering explores new ways to leverage their unique properties for innovative solutions across various industries. So in this smart materials, just now we discussed already what is the meaning of smart materials. So these materials are having properties that can be altered or changed in a controlled manner in response to external stimuli such as temperature, stress, pH, magnetic fields, etc. So that's why these materials have various engineering applications due to their ability to adapt their changing conditions. So here, most important in this smart materials are shape memory materials. The best example of shape memory materials is polylactic acid, PLLA. Polylactic acid is the best example of shape memory material. It is a type of smart material. So already we discussed what is the meaning of shape memory materials. So shape memory materials or shape memory alloys is an alloys, the mixture of metal, that means that can be deformed when cold. That can, for example, here original shape in cool conditions or cold conditions or rest, when we applied force in that material, it can be deformed, bent. That means it can be deformed. During heating process, it can be pre-deformed. That means remembered, original shape. So this type of materials are called shape memory materials. They are changing their shape depends on temperature. The type of materials are called shape memory materials. Already we discussed where we can use this shape memory materials. What are the engineering applications of shape memory materials? So it is used in biomedical devices. So the shape memory alloys are used in biomedical devices, like for example stents, where they can compress it for insertion and then expand it to their desired shape once inside the body. So this smart materials, shape memory materials used in biomedical devices, for example stents, and also used in aerospace engineering. So these materials used in aerospace applications for deployable structures, for example such as antennas and solar panels, antennas and solar panels that can be compact during transport and then unfold in space. So these shape memory materials used in biomedical devices and also used in aerospace engineering and also used in actuators and sensors. So here shape memory polymers find applications in actuators and sensors for robotics, where precise movements are required. In that case, we are using this shape memory materials. So in this best example of shape memory material is polylactic acid. Polylactic acid is the best example of shape memory materials. So here this polylactic acid or PLLA, polylactic acid, is chosen as a polymer with shape memory properties. That means this is the best example of shape memory material. So this polylactic acid is a biodegradable. That means it is easily undergoes degradation by enzymatic reactions or microorganisms. So do not harmful for environment. So this polylactic acid is biodegradable and bioactive thermoplastic. Thermoplastic means during soft on heating, hard on cooling. The type of plastics are called thermoplastics. Soft on heating, hard on cooling. So polylactic acid is a biodegradable and bioactive thermoplastic. So this polymer is made from renewable resources. This polymer is made from renewable resources such as starch, sugarcane, etc. So polylactic acid is the best example of shape memory material. That means it is having shape memory properties. That means during cold condition, it can be deformed. When we heating, it can be re-deformed. That means remember same original shape. So it is having small shape memory properties. So it is a biodegradable and bioactive thermoplastic. It is made from renewable resources such as starch, sugarcane, etc. So how can you prepare this polylactic acid or polylactic acid? So it is prepared by the catalytic dimerization of lactic acid resulting in the formation of lactide monomer. It is prepared by the catalytic dimerization of lactic acid resulting in the formation of lactide monomer. So the polymerization of lactide monomer in the presence of stannous octet to give lactic acid. So this is a preparation of polylactic acid or polylactic acid. So for example here lactic acid, it is undergoes catalytic dimerization, so removal of water molecule, then it gives lactide monomer cyclic structure. So when it is undergoes polymerization in the presence of stannous octet C16H30O4SN, stannous octet, then it gives polylactic acid. It gives or polylactic acid. This is a preparation of polylactic acid. So what are the properties of polylactic acid? It is having all shape memory materials properties, already we know that, and also it is having various properties. It is used in various applications also because of it exhibits range of properties that is suitable for various applications. So what are the properties of polylactic acid? To use it for biodegradability. So already we know that biodegradation means it is easily undergoes degradation. Do not harmful for environment. It easily undergoes degradation by enzymatic reactions or microorganisms. Do not harmful for environment. So eco-friendly material. And biocompatibility. So it is safe for use in medical and food contact application due to its biocompatibility. But that means biocompatibility and less toxicity or non-toxicity nature. So that's why mainly used in this medical field and also used in food contact applications because it is non-toxic. And transparency. So PLA, polylactic acid is transparent and it can be made into clear and glassy product. Clear and glossy products. And renewable sources. So already we know that this polylactic acid is derived from renewable resources such as starch, sugarcane, corn, etc. And rigidity. Rigidity means hardness, toughness. So it is offers good rigidity and can be engineered to be similar in strength to conventional plastics. It is strong. So that purpose we are using strengthened to conventional plastic preparation purpose we are using. And heat resistance. So this polylactic acid has moderate heat resistance, but it may deform at relatively low temperature because it is having shape memory properties. So it may deform at low temperature and limiting its use in high temperature applications also. At high temperature it can be remolded and it can remember the original shape it comes at high temperature. So it is having heat resistance and brittleness. So it can be somewhat brittle. So which can affect its use in application required impact resistance. And also having barrier properties. So it has reasonable barrier properties against moisture and gases. Moisture and gases. So these are the properties of polylactic acid and best example of shape memory material. That means is having shape memory properties and it is a bioactive, biodegradable thermoplastic. It is one type of shape memory materials. It means smart material. So what are the applications of polylactic acid or polylactic acid uses? So this it finds applications in various industries due to its unique properties. So it is used for packing. So this polylactic acid or polylactic acid used for producing biodegradable and compostable packaging materials such as disposable cups, plates, food containers, films. So that purpose packaging purpose we are using this polylactic acid because it is a biodegradable polymer. And textiles. In textile industry also we prefer this material, this polymers, polylactic acid materials because these PLA fibers used in this industry to produce biodegradable and sustainable fabrics. Biodegradable and sustainable fabrics. And also used in medical and healthcare. Medical and healthcare. So it is used in medical devices. So such as tissue engineering scaffolds and drug delivery systems. So many medical fields we are using because it is having biocompatibility, a non-toxic nature. So that's why we prefer in this medical field. Medical application purpose we are using this polylactic acid or polylactic acid material. 3D printing. So this polylactic acid is a popular material for 3D printing due to its ease of use, biodegradability and available in various colors. So that's why most preferred for this 3D printing purpose we are using this material. And filaments. So it is used in the manufacturing of filaments for fused deposition molding in 3D printers. And also used in this biodegradable films. So these are used for agricultural applications. That means such as much mulch films forms. They can be flowed into the soil after use. And disposable tableware. So this polylactic acid is used to produce disposable plates, bowls, and utensils for single-use application purpose. We are using this material because it is having biodegradability and biocompatibility. And consumers goods. So this polylactic acid can be found in consumer goods like toys, cutlery, and cosmetic packagings. So this is having why we are using so many applications because it is having unique properties. So in this session, we'll learn about what is smart material, classification of smart materials, and in the smart materials mainly we discussed about shape memory materials, what are the engineering applications of shape memory materials, and best example is polylactic acid preparation properties uses we discussed in this session. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.